Welcome back. Now, in the previous class, we have discussed about the NC machines and what is CNC machines. We have already discussed about how to decide the fixed zero and floating zero on the machine. So today we will discuss about the NC motion control system. So in order to accomplish the machining process, the cutting tool and workpiece must be moved relatively to each other. So in CNC, there are three basic type of motion control system, in which the first control system is called as point-to-point NC control system, which is you can say it is representing the lowest level of motion control between the tool and workpiece. Whereas the second is called as the straight cut NC machines, and the third one is called as the contouring machine, and contouring is one of the highest level of control system. So point to point, sometimes it is called as the positioning system. This is used for basically in the case of the drilling operation, where the objective of the machine tool is to control the system and is to move the cutting tool to a predefined location. Predefined location means we have to first set the target points where we have to drill the holes and find out their coordinates. It means the x coordinate and y coordinate, and then we have to develop a program, write a program and give the coordinates so that the tool should move quickly on the target point. Say suppose if we consider this is a first target point where we have to drill a hole, therefore we have to first set the coordinate, it means the x and y coordinate of this target point, and then once the operation is completed, when we give the feet of the spindle in z direction, and if this operation is performed on the first target point, the tool will move quickly on the second target point to repeat the operation. If the diameter of the holes of all cases are same, then if there is no need to change the tool, then what happening, we have to give only the coordinates of the target point and the tool will perform its duty or its operation at the different points. So this type of operation is called as the point-to-point NC control. So it is very clear that when the tools reaches the desired location, the machining operation is performed at that position. Now NC drill press are the good example of the PTP system. As I told you, the spindle must first be positioned at the particular location on the workpiece. Now this is done under the PTP control. Then the drilling of the hole is performed at the location, and it will continue till the complete operation is performed. So therefore, there is no cutting is performed between the holes. You can say that in between hole 1 and between hole 2, there is no another cutting operation, only we have to drill the holes. Then there is no need to control the relative motion of the tool and the workpiece between the hole location. So it means you can say that you can move the tool rapidly without deciding the any other motion of the tool related to the workpiece. Without bothering it, we can give only the target points. So this is basically the simplest type of controlling system. The next is the straight cut system. Straight cut system means if suppose we have to say for example using the milling operation, or you can say you have to use the end milling operation. Now the tool has to follow the surface. In that case, we have to decide the path of the tool, and this tool will move along with the surface of the workpiece to perform its operation. So suppose we have to use the state movement of the tool. Now therefore we have to use the state cut of the NC controlling system, right? So suppose if this is the starting position of the tool, and this tool will move along the surface or along the edges of the you can say the workpiece, and remove the material from the edges. So the tool will move parallel to either x-axis or parallel to y-axis. Now this type of operation is called as the NC straight cut operation. Now it basically depends upon the configuration of the plate. Sometimes, for a example, if there are some straight edges, or you can say the rectangular type of plate, it can be basically as named as a straight cut on the NC machines. So we know that the NC machine capable to straight cut movement is also capable for PTP movement. Next is the contouring type. Contouring type is the most, you can say, the difficult operation, or you can say the most complex operation, and the most flexible and most expensive type of machining tool control, right? So it is capable to performing both PTP and straight cut operations. You can observe here that suppose if we want to cut the motion in this shape or the curve shape, or sometimes in some cases there are some straight edges, and then again it should be switch over to the circular interpolation or the circular cut, then we have to use the contouring type of NC system. So because we have to develop a program also for such type of system, or you can say for such type of complex operations, right? So that's why it is called as it is the most complex operations. Now, in addition, the distinguished feature of the contouring NC system is there the capacity of simultaneous control of more than one axis movement on the machine tool. So therefore, the path of the cutter is continuously controlled to generate the desired geometry of the workpiece. You can see here that sometimes it is straight, sometimes it is a curve. Okay, so the tool should move according to the requirement of the tool, this path. So therefore, we can say that for this reason, the contouring system are also called continuous path NC system. So straight or plane surfaces at the orientation, circular path, conical shape, or most any other mathematically definable form are possible under contouring control. You can see in this figure the versatility of continuous path NC machine milling machine and turning operations are common example of the use of contouring control. So we can understand that they are depending upon the geometry of the workpiece, or you can say the geometry of the final operation needed, and we have to change or plan the program on the NC machine. Okay, so here we have to understand that what is the structure of the main program. I have used here the Denford CNC control program as a reference. So in this program is divided into basically the 4 steps, or you can say the 4 blocks, where you can say that blocks, where we have to use the CAD/CAM software. In this case, we have to use the first information of the machine, that what type of your system, which is you can say the what type of controller is used in the machine. So the basic machine information is illustrated here in this figure, in this block, and we have to use the CAD/CAM software package information, which should be written first in the program structure. And normally this is not fed by the operator. This is self-generated. When you write the program, this first information will be already you can say that taken by the machine. The second one is the program number. You can observe here that this is a very interesting thing. It is a numeric value or a number which is defined here. So for example, 00050. Now this is a number, right? So it has a 5 digits, and we have to use this digits on the basis of the length of the program. So for example, if you say 1 digit or 2 digit number as a program, Now you can say this is the limitation of the number of steps in the program. So you can write down up to, say for example, 99 steps only if it consists of only 2 digits, right? See, suppose if you want to in future, or if you want to add say for example 1 or 2 steps, okay, you will not be able to increase the steps in this program because you have used this number. Now this number define the first the you can say that it will define the step of the program, or you can say the sequence of the program, which is first we have to write down and then you define the program number first. So normally, depending upon the capacity of the, or you can say the length of the program, we have to use this flexibility in the program number in thousand, or you can say 10,000. You can say that the number system. Next is where we have to define the units of the coordinate system, or the length, or you can say the feed. So you have to use here the unit system and then find out here the first this whether it is a metric system or GI unit or any unit, we have to define here the unit, right? Next is the main programming information. You can see here that from here to here, this is the main program, which is where we perform the actual operation on the machine, right? So what happening, suppose N020, this is the number of the program, right? And G91, G28 and XY0, these are the coordinates of the system which we have to use, Cartesian coordinates, whether it is representing the machine coordinate or the tool coordinate or work coordinate, right? So we will understand later on what is the meaning of G code and M code in detail, but just have a look that how this program is appearing on the system or on the machine or in the system computer system, where you can actually simulate the operation, right? So this is basically the length of the program, and at the end we have to end or close the program. So it means your machine will execute its process while reading this program, and after that we have to close this program with the help of some M code, M30, which is used to stop the program, right? So this is the body of the main program structure. Now, as I told you that we sometimes call some programs which may not be the part of the main program, but sometimes it is called, right? And then suppose if this is the main program structure, which we have already seen in the previous slide. Now, sometimes what happening in this slide, we can understand the role of the subprogram, right? So suppose if there is any operation changes, or any suppose if you want to call the another program in the main program, we can use this number here and call this program. Say for example, the subprogram initial number is 01000, right? And the last number is N0160. It means it has 160 steps here, right? 160 steps means in the difference of 10. So 1 2 3, okay, like this. So you have to check this sub program, and this program will be inserted here and call it, and then what happening, your main program will execute the operation. So therefore from this to this, your main program will end. Once you call the program at here, your this program will be switch over to the sub program, and your machine will execute this complete program, sorry, this complete program, and again we'll move to the main program. Similarly, if there is any another program also which is inserted, for example, I want to insert one more program in the subprogram 1. Say for example, at this step we can use another subprogram 2, right? And it will move in a similar fashion to the main program, right? So this is basically the subprogram structure. Subprogram is written which may not be the part of the main program, or maybe the part depending upon the need or requirement, or you can say the final geometry of the workpiece. We can call the subprogram structure, and this is the structure. Okay, as I told you that there is a program number, because as you said that in a class if there are 30 students, every students have their own roll number, and teachers will call the student while taking the attendance, and they call the students with their roll number, right? So similarly, in the programming, we understand the step of the programming, right, with their number. So as I told you that the subprogram number must be saved between 20012 to 999, right? So we can use here 4-digit numbers, and it is recommended that all programs saved have file names also between these numbers. Next is we can use this program, say that in the controller also, for example, FANUC controller, which is mostly used in the machines. So we use first code as a O, which define a basically N or as a number of the program, or you can use here O any number, a alphabet number, and after that we have to use the 4-digit program number, okay, or 5-digit program number. Here we have to define the step of the program. So this is basically the programming number which is used to save in the system, and you can use this program as a execution of the machine. Okay, so here we have to understand that what is the meaning of the block configuration. Block configuration means in a complete block. So as I told you that programming has some sequence of operations, right? So one line represent in a program a block. One line in a program represent a block, right? So at the end of the block, we have to use the semicolon to terminate the block. It means your machine will run only this single block, and when you use this semicolon here, and if there is any you can say numerical or any numbers are written after that, your machine will not execute further once you use the end of block signal, right? So let us try to understand the structure of this block. First, as I told you, we have to define the block sequence number, because every block will called with its number, which is called as the sequence number, block sequence number. So as I told you that this is a n is basically the number 000, right? Now this is the number which defines the block number. Next is the preparatory function. We know that G codes are used as a preparatory functions. So this will use to G00 is one preparatory function, where we can use the different type of preparatory functions, say for example G01, G02, G03 and so on, G04, like this. So there are some preparatory functions which depend upon the machine configurations and which are used to write the program. This is the preparatory function for which we prepare the machine, right? It means the first step which is used to execute. It means you have to just move the tool to set the 0 position of the machine or any tool, right? Then we have to use the interpolation function. Interpolation is basically, or interpolator is basically, it is the input speed is converted into the velocity of component by an interpolator called the linear interpolator, whose function is to provide the velocity signal to x and y direction. So similarly, there are circular and parabolic interpolator also. We'll discuss later on in the next slide. So we have to use some interpolation function also, whether it is a clockwise interpolator or anti-clockwise interpolator in the case of your curvilinear motion of the tool. Next is the feed rate function. Here f is used to define the feed rate, right? What feed rate we have to given. Then next is the miscellaneous function. Sometimes it is needed to change the tool to you can say the change the speed of the tool, or some other miscellaneous functions which is necessary to use. We can use this function in between the block. Next is the spindle function. So spindle speed and spindle function can be used here, and we can decide the speed in revolution per minute, okay, and or RPM. We can use define the first the speed of the spindle here. Next is the tool function, right? So we use here T as the alphabet to define the tool function here. So T00 is the one code which define the tool function. Then at the last we have to stop the block, or we have to turn to the next step of the program, and your machine will read the next block. Okay, now if we try to understand the tool movement, so as we have seen in the previous case, sometimes we want to move the tool movement along the straight line. So we have to use this type of program command format G01 Y, and then we have to define the target point, say P1 to P2. So your T tool will move in a straight line from point P1 to P2, right? And then after that, we have to move the tool further, or you direct the tool from point P2 to P3 directly. You can simply define here the coordinates or in X and Y direction for the definition of P2 and P3, right? So you have to define the coordinates. Suppose, for example, we have to consider the coordinate of P1 points is say the coordinate of X1 and Y1. Similarly, you calculate the coordinate, a Cartesian coordinate of point P2, X2 and P2, X3 and P3, and so on, right? So your tool will move by giving the direction in the program, so that you can move the tool along the straight line with the help of this Cartesian coordinates use. Okay, the tool movement along the arc. Suppose in this case, if you want to turn the tool, or you want to turn the tool in a arc, you need to define the radius and the initial point and the final point in the movement of the program. So this command will be 03 X and Y coordinate, and then define here the radius at which you want to turn the tool, right? For moving the tool from position 1 to position 2. So this P1 to P2, if you want to rotate the or move the tool in a circular fashion, you have to use this type of command or format to move the tool from straight line to the curvilinear, and this is called as the interpolation. So we have to use the command G01, G02 and G03, which are called the preparatory function, and specify the type of interpolation, whether you want to move the clockwise direction or anti-clockwise direction. So you have to use here G01, G02 and G03. Then we have is criteria of the feed function also. So we can use G20 code to define the feed rate in inches per minute, and the preparatory function of G21 code, where we have to define in millimeter per minute. So here we not define the feed. Basically here we have to define first the unit, whether it is inches per minute or millimeter per minute. Then next is the miscellaneous code or M codes. M codes are basically used for the spindle speed. Spindle is moving in clockwise direction, right? Spindle stop motions or etc. Then sometimes we can use the tool your coolant start or stop. Okay, so we use this type of codes. M00 codes are used as a miscellaneous. So there are some more codes, M01, M02. So M is basically, this is the address of the code, and 2-digit numbers are used to define the M code or miscellaneous function codes. Okay, here we can also define the spindle speed in revolution per minute, right, in RPM, because without defining the spindle speed, you cannot find out the finishing of the workpiece. Okay, so it is very necessary in a program, you have to define the spindle speed. So suppose when a move command and the S code are specified in the same block, a simultaneous execution of the command is performed. So only S code is allowed in each program block. We have to use a S first alphabet to define the spindle speed. Now next is the tool function. Tool function is very important to understand, because we have to use sometimes the ATC automatic tool changer. You can see here that this is the ATC magazine, or where this is used to store the tools in the magazine, in a single magazine. So suppose if we are using 8 number of slots, where we can position the tools in the periphery of the cutting slot. So suppose if we use tool number 1, we have to define this tool number 1 in the program also. So suppose if you want to position this tool first tool against the workpiece, you have to first define this tool in the program. So M06 means this is basically used to precede the number of the new tool which is required, right? So T01 is, it means the first tool which should be come in front of the workpiece and perform its operation. After that, suppose if you want to use here, say for example, if you want to change the tool number 1 with the tool number 4, right? You don't want to use tool number 2 or tool number 3. You want to move quickly on the tool number 4 and want to use this tool for the operation, further operation. We can use here that M06 is the tool change and T04 code as a tool number 4 must come in front of the workpiece. So this command is read to perform a tool change and tool number, any tool number which you want to define here, whether tool number 01 or tool number 04. Okay, so this is very interesting. You can say that command which is used to define first the tool, mainly with the help of ATC. It means the automatic tool changer. If you are not using any automatic tool changer or using a single tool for the cutting operation, then again you have to define the tool also. It means T01. It means you are using by default number T01 in the machine. Okay, tool compensation. See, tool compensation is also known as tool offset. See what happening for different tool profiles which are required to machine a workpiece, all of different diameters and length. Because machine does not know that what is the length, projected length of the tool. Machine does not know that what is the diameter of the drill hole or drill piece, right? But we know that, yes, at this distance, we have to move the tool in forward direction. This diameter of the drill is required or hole is required. So we have to use the tool compensation, because what happening over a period of time, you know that there are so many problem associated by, because the tool is always subjected to a friction, right? And therefore the tool dimensions may be disturbed. So in that case, we have to use the tool offset, which is you can say a type of allowance, or you can say the tool compensation, where we can actually drill the hole, right? And this compensation is between the workpiece and the machine tool, right? So this we can use that T42 tool compensation left to right and must be programmed for the radius offset to use. Next mode is called as the absolute and incremental coordinates. See, absolute coordinates are basically used that in the addresses X, Y, and Z within a program. When G90 code is used to for the absolute coordinates, right? Absolute coordinate is basically, it is active and it is related to a coordinate position from the workpiece datum to zero position. Datum or zero position means basically, we, as I know that the initial position of the tool must be defined first, right? Or you can say it is the home position of the tool, which is already set, or you can define, operator can define. So your tool will start to move from this zero position to this position P1. It is the first position where the first execute should be taken. So this is basically, you can say that this is the position where the tool or the machine should move very fast. Okay, or it is called the rapid motion, right? Therefore, after that, the tool should move in this direction and remove the material from the surface. Okay, so that is basically called as the absolute motion. So what happening here, to define here the target points first, like the your first point is say P1 to P2. Okay, so from here to here you have to move the tool in linear direction, and from here to here you have to move the curve motion, and further it will move in the horizontal direction in X direction, right? So this is basically the absolute and incremental coordinate system. Okay, this we have to discuss that G code is the preparatory function. Preparatory functions are used to determine the geometry of the tool movements and operating state of the machine controller. Functions such as linear cutting movement, drilling operation, and specifying the unit of the movement. So G00 or G01, G04 are basically, these are the preparatory functions or G codes. Now these here you can see some G codes. Okay, so that you can understand that this Denford CNC control is used, this type of, and it is some most common, some proprietary codes are very common for other machine also. So for example, G00 is used for the rapid transfer. As I have discussed that where the actual operation is not uh, running, we have to move the tool quickly from the home position to the first target point, and this is called as the rapid transfers, right? Then is the linear interpolation. It means we have to move the tool in linear direction, G01. Then circular interpolation in clockwise direction. For this, you have to use G02. Counterclockwise direction, G0T, G03, right? Dwell and exact stop. Suppose if you want to provide a stop motion at particular distance, you can use this function. Then similarly, you can, there are a number of lists which are available and which need not be used here, need not be remember. These codes are given with the machine, right? The interesting thing which I have used here and marked start, that this is known as the canned cycle. Canned cycle is a cycle where a machine should run the program or repeat the program at number of times. So suppose example, if you want to perform a same operation, a similar kind of operation for multiple of times, say 100 times, right? So we have to use a small cycle which is called as canned cycle, and this canned cycle is a small program which uh, work in a loop, right? So it is basically used in a repetitive operations. Then G81 is the drilling cycle, spot boring, G82, like this. There are so many operations which needs to be performed, and then accordingly the G codes are used. Okay, there are some more G codes which are also given here, right? So I have marked here some start functions also. This is a basically absolute zero command, feet per minute. Your G98 is returned to initial level in a canned cycle, right? G99 is returned to R point level in a canned cycle, means you have to define another point in a canned cycle intermediate. Then it will move according to the code which is used in the program. So G0 is the rapid positioning system. I would like to move very quickly in this case. M codes are basically, these are the miscellaneous function codes which are called M codes, and which are used by the CNC to command on a signal to the machine functions. Say for example, M03 is used to spindle move forward in clockwise direction, right? M05 is used to spindle stop. Therefore, there are so many miscellaneous functions which are associated with the machines or during the operation which needs to be considered. For that, we have to use the M codes. So M codes are basically defined using the M address letter here and the two-digit number as follows. So this is basically M00 code, M03 code, M02 code, M05 code, like this. So this is the complete list of the M codes. So you can go through this list also, that M00 code is used for program stop, M01 is optional stop, right? M03 is spindle forward in clockwise direction, M04 is spindle reverse in counterclockwise direction, and similarly M08 is used to coolant off, M09 is coolant off, right? Coolant on and coolant off, right? then ATC alarm in. Like this, you can see here a long list which is used for the M code, miscellaneous functions. For example, door open, door close of the machine. We have to use M38, MM39 to open and close automatically the door of the machine. Thank you very much. This is a simple brief of the, you can say that the control system on the CNC machine, and how we can use the G code and M code, right? But there are lots of details which are available when you go through the entire CNC operations and CNC machines, right? When you write the program according to the surface geometry of the workpiece. Thank you very much. Thanks.